So with this video, we're going to look at the pH scale, and I'm going to give you kind of an introduction to what pH stands for, what we're measuring with pH, and then we'll look at the actual scale itself and how to tell an acid from a base and those kinds of things. So pH stands for potential of hydrogen, and hydrogen, of course, is that atom that most often exists as an ion, as a cation. And what we're measuring when we measure pH basically is how much hydrogen ion there is, and specifically how much free hydrogen. And I remember when I was first learning this, I didn't really understand what that meant, like what was meant by free hydrogen. So I want to explain that to you because it's really important to getting this concept. So what I've drawn in here is just a beaker that has a solution in it. So the solution is water, and when you're drinking water, when you see water in a river, it isn't just pure H2O, it's H2O with a lot of different things that are floating around in it. So it's a solution. But if you look at this beaker that I've drawn here, we've got some water molecules, and we've got some OH minus, which is known as hydroxyl ion, just another chemical that's floating around in there. And we have some hydrogen ion. And you'll notice that in its ionic form, as it's floating around in this water, that's our free hydrogen. It's not bound to anything else. So over here with our hydroxyl ion, we have a hydrogen that's bound to an oxygen. That's not free hydrogen. It's not what we're measuring when we talk about pH. Up here with just the water molecules, we've got two hydrogen atoms that are bound to oxygen. Because it's bound, it's not free. So it's not what we're looking for. It's not what we're counting when we're talking about free hydrogen. We're really looking for just that hydrogen ion that's floating around in a solution. So the pH scale ranges from 0 to 14, with 7 being right in the middle of that, and 7 is what's considered to be a neutral pH. If you look at this diagram here, these pH values from 0 up to 6.99999, those are acidic pH values, and what that means is you have a solution where there's relatively more free hydrogen, and that's what's causing the pH to be lower than neutral, and causing the acidic pH. If you look at this part of the diagram over here, all of these values ranging from just above 7 up to 14 are considered to be what's known as basic or alkaline. And the reason that they're basic or alkaline is because the amount of free hydrogen is relatively low. So there's more of that hydroxyl ion, less of the free hydrogen. I want to give you some examples of substances that you're probably familiar with that kind of fall on the pH scale and where they would actually fall. So black coffee, okay, has a pH of 5. And what we see is tomato juice has a pH of 4. And what that means as the pH becomes increasingly lower is you're getting more and more of the free hydrogen. So what we see is that tomato juice actually has about 10 times the amount of free hydrogen that black coffee has. Over here on the other end of the scale, human blood sits right at about 7.4, so your blood is not neutral. It's actually slightly alkaline. The only substance that I can think of that is like straight neutral is distilled water, and it has a pH of 7.0, so that's our neutral. Just to give you another example of an alkaline substance, bleach, so that household cleaner is really alkaline. Its pH tends to be about 13. So what that means is that we've got less free hydrogen for those things that are basic or alkaline, and as we go from lower pHs to higher pHs, the amount of free hydrogen in the solution decreases. So human blood, which has almost a neutral pH, it's just that side of alkaline, has far less hydroxyl ion and far more hydrogen ion than does bleach with a pH of 13, which has almost no of the free hydrogen ion. So that's the pH scale, and in a nutshell, what pH is measuring and how we actually measure it.